Welcome to Dear Math online tutorial. This video will cover 10th grade math with our topic Arithmetic Sequence Part 1. The topic will be divided into two videos, so make sure to watch the second part after this. Are you ready for arithmetic sequence? Before that, let's have the learning objectives. At the end of this video, you must be able to determine if a sequence is arithmetic or not. Also, you must be able to find the common difference and the nth term of a given sequence using the formula a sub n equals a sub 1 plus n minus 1 times d. Before going to arithmetic sequence, let's define a number sequence first. A number sequence is a list of numbers having a first number, a second number, a third number, and so on, called the terms of sequence. In the sequence 1, 2, 3, 4, and so on, you have the terms labeled as what place they are in the sequence. We have the first term, the second term, the third term, the fourth term, and so on. This can go on forever, and that is represented by these three dots called ellipses. If you are going to study the sequence, you can observe a pattern. For us to get the next term, we just have to add 1, right? How about getting another sequence? Another example is 5, 10, 20, 40, and so on. If you will be asked to observe a pattern, you can say that in order to get the next term, we multiply 2 by 40. Therefore, the fifth term must be 80. A number sequence has many types. We have arithmetic, geometric, harmonic, and more. But for this video, we will focus on arithmetic sequence. Arithmetic sequence is a number sequence in which a constant d can be added to each term to get the next term. We have an example 3, 5, 7, 9, and so on. Remember that arithmetic sequences are sometimes called arithmetic progressions. Let's now label the terms. 3 is the first term, 5 is the second term, 7 is the third term, and 9 is the fourth term. The second term was obtained by adding 2 to the first term, 3. 3 plus 2, 5. The third term was obtained by adding 2 to the second term. 5 plus 2, 7. And the fourth term was obtained by adding 2 to the third term. 7 plus 2, 9. The constant d in this sequence is 2. The constant d is called the common difference. To find the common difference, we subtract any term from its next term. Meaning, we have 3 and 5. All you have to do is subtract 5 minus 3. Here are the terms. 5 minus 3, 2. 7 minus 5, 2. 9 minus 7 equals 2. We have to subtract consecutive terms to get the common difference. Note that the difference must be the same for all terms. Can we find the next terms for this sequence? In order to find the next terms, we just add the common difference to the last term. Example, if our last term is 9, to get the next term, we just add 2. Therefore, the next term must be 11, followed by 13, and so on. Now, let's verify if the following sequences are arithmetic. Remember that in arithmetic sequences, there is a common difference between two consecutive terms. And that can be obtained by subtracting a term from its next term. Let's try. Number 1, 7, 13, 19, 25, and so on. Let's subtract consecutive terms. 13 minus 7 equals 6. 19 minus 13 equals 6. 25 minus 19 equals 6. Therefore, the common difference is 6. And it is an arithmetic sequence. Nice job. How about number 2? For number 2, we can do the same thing. Of course, we subtract consecutive terms. 4 minus 6, negative 2. 2 minus 4, it's negative 2. And 0 minus 2 equals negative 2. Yes, we can have a common difference which is negative. This just means that arithmetic sequences can be a decreasing sequence. Okay, or arithmetic sequences can either be an increasing or decreasing sequences. For number 2, it is a decreasing sequence. The common difference is negative 2, and yes, it is an arithmetic sequence. But how about number 3? Number 3, let's check. 6 minus 3, 3. 10 minus 6, 4. 4 minus 10, 4. What can you say about the differences? Okay, we don't have common differences. Therefore, this is not an arithmetic sequence. Now, let's have another sequence. But this time, we are given a different problem. Find the ninth term of the arithmetic sequence 12, 20, 28, and so on. Let me label the terms as first term, second term, third term, and we are looking for the ninth term. First things first, I need to check the common difference. I subtract 20 minus 12 equals 8. Subtract 28 minus 20 equals 8. The common difference is obviously 8. How are we going to get the ninth term? For us to get to the ninth term, we must get through the fourth term, the fifth term, the sixth term, until we get to the ninth term. How are we going to do that? You get the original sequence, and since we have the common difference, all we have to do is add the common difference to the last term. 28 plus 8 is 36. 36 plus 8 is 44. 44 plus 8 is 52 plus 8, 60 plus 8, 68 plus 8, 76. If we're going to count the terms, 76 is the ninth term. And that is the answer for this problem. As you see, the concept may be too simple because all we have to do is add the common difference to get our desired term. But what if we will be asked to find the 50th term, the 100th term? Will you still find it easy or simple? It will be too dragging and too long for us to get to that term, to the 50th or the 100th term. Now, let me introduce to you the formula for the arithmetic sequence. The formula is a sub n equals a sub 1 plus n minus 1 times d, where a sub 1 stands for the first term, n refers to the number of terms, and d is the common difference. What about a sub n? Well, a sub n is the missing term. It's the one we are trying to solve, or we are trying to find. A sub n can also represent the last term of the sequence. How about trying this formula with the previous example? Find the ninth term of 12, 20, and 28. Get the formula? First step is to list the information provided in the problem. So, a sub 1 is 12 because the first term in the sequence is 12. N is 9 because you are given the ninth term. Therefore, there will be 9 terms in the sequence. D, or the common difference, can be obtained by subtracting 20 and 12. 20 minus 12 is 8. And we are just looking for a sub n, or a sub 9, the ninth term. Next, we substitute everything in the formula. We have a sub 9 equals 12 plus 9 minus 1 times 8. Now let's apply PMDAS. Let's simplify the terms in the parentheses first. Therefore, we'll have a sub 9 equals 12 plus 8 times 8. Then we multiply 8 times 8. It will be a sub 9 equals 12 plus 64. Then all we do is add. 12 plus 64 is 76. And this is correct because we got the same answer from the previous slides. Cool. Do you have questions about this example? Or do you have questions about the concepts of arithmetic sequence? If you have, you can comment your questions and we will find time to answer them. If you want an access to more practices about this topic, you can like and follow our page in Facebook. Search Dear Math. Do not forget to like, okay? Send us a message asking for the worksheet, and it's all for free. We really want to help students like you. Let's go back to our learning objectives. Do you think we were able to achieve these objectives? If yes, then mission complete. Don't forget to give us a like and subscribe to our channel. Now I have a challenge question that requires your participation. Find the 20th term of the arithmetic sequence with second term of 8 and the common difference is 5. Quite challenging, huh? Now, comment your answer and students with correct answers will be given a shout out to the next video. Okay? Thank you very much for listening and learning with us. Have a great day.